Hello students, welcome back to my channel. Today I have come up with around 6 to 7 questions. They have been picked from thermodynamics, general properties of matter, waves and SHM 2023 NEET. So without wasting time, let us discuss them. So here comes the first question. Let a wire be suspended from the ceiling and stretched by weight W stretched attached at its free end. The longitudinal stress at any point of cross-sectional area A of the wire is. Now, students, this very fundamental thing, just to should be able to answer this very easily. Here we'll be assuming that the wire is massless. There is no wire. There is no mass of the wire. So when a weight W is attached at the lower end, then anywhere you can see anywhere there will be tension. That tension is actually that is the cause of the longitudinal stress. So longitudinal stress is nothing but that tension divided by cross-sectional area. So longitudinal stress is nothing but tension prevailing at any point upon area. Now tension is nothing but the restoring force actually. So here if you consider the equilibrium, then you can write T is equal to W. So tension is equal to W and cross-section area they have given as A. So at any point, the tension will remain same. So accordingly, the stress will also remain same. So first option is the correct answer. Moving on to the next question. The amount of energy required to form a soap bubble of radius 2 cm from a soap solution is nearly. Now we all know that whenever a liquid surface is formed, it requires additional energy because the molecules present on the liquid surface, they always have additional energy as compared to the molecules which lie well within the liquid. Okay, because in order to come to the surface, the molecules have to do work against the intermolecular forces of attraction, which tend to pull the molecules within the liquid. So, by overcoming these forces only, the molecules are capable of coming to the surface. So, molecules lying on the surface of liquid, they always have excess energy. So, that excess energy need to be provided whenever the surface is increased. So, that means here the amount of energy required will be energy required per unit area. What will be the energy required per unit area multiplied by the area of surface. Now energy required per unit area is actually surface tension. You must be knowing this. Additional energy required per unit area is the surface tension multiplied by area of surface. Now a soap bubble has two surfaces, one inner and the other outer. So total surface area will be 4 pi r square multiplied by 2. One for the inner surface and the other for the outer surface. Substituting the values we get. Surface tension is given as 0.03. I'll write it as 3 by 100 in SI unit. Then 3.14 pi. Radius is 2 centimeter. So convert it into meter by multiplying by dividing by 100. So here we have 2 to the 4, 4 to the 8, and this will be 12. So 12 into 8 into 3.14 into 10 to the power minus 6. So what I am going to do is this, because the options are in 10 power minus 4, I'll give 110, I'll bring 110 below this and another 10 below this. Okay, out of this I have taken two powers of 10, so I will end with this. Okay, so this is approximately 8 is a 24. 24 can be treated as 25. 25 into 12 is around 36, 316 approx. Okay, by 100. So 0 gets cancelled. So this will be 24 into 25 12s are 25 12s are 300 something 300. So approximately this is around 3 point something into 10 to the power minus 4 joule. So this is the first option. First option is the correct answer. Students, again I'll advise you to never ever solve the question completely. Never calculate the complete thing. As far as possible, try to avoid calculation, because if you keep calculating, you will be losing time. Okay, so the best way to avoid losing time is to avoid calculating. Of course, in certain cases you need to calculate, but apart from those situations, usually try not to calculate. Try to reach as close as possible to the correct answer. Then comes the next question. Venturi meter works on. Venturi meter is also known as a flow meter. It basically measures the rate of flow. Rate of flow means the volume flowing per unit time interval, okay, which is cross section area into velocity. This you know as per the principle of continuity and Bernoulli's theorem together. So this basically works in the principle of Bernoulli's theorem. Then moving on to the next question. The temperature of a gas is minus 50 degrees Celsius. To what temperature the gas should be heated so that the root mean square speed is increased by 3 times? Now again we'll be using the shortcut method. Students, always try to apply shortcut methods in these kind of questions. So first thing is that you should know the dependence of temperature on RMS speed. Dependence of temperature. So dependence of temperature on RMS speed is this. V square is proportional to T. Okay. This formula you know this formula, isn't it? V is equal to under root 3 RT by R. This formula, all of you know this. The capital M is the molecular mass, R is the universal gas constant, and T is the absolute temperature. So what I'll do is that I'll write T proportional to V, because we have to find temperature. So whatever need to be found out, keep it onto the left hand side, and whatever information is provided, keep it to the right hand side. Now let us calculate the factor of change of velocity. Velocity is increased by 3 times. Means the new value is original value plus 3 times, that is 4 times. So the factor of change for velocity is how much? 4. So 4 square is 16. So the factor of change for T is 16. That is, the new temperature is 16 times the initial temperature. What is the initial temperature? Initial temperature in Kelvin will be 273 minus 50, that is 223 Kelvin. Remember students, this temperature is always in Kelvin. Okay. So 16 times of 223 Kelvin. Now here, as you can see, that just see this 16 twos is 32. So in Kelvin itself it is going beyond 32. Okay, and then we have to add what 273 to convert it into degree Celsius. So certainly the only, sorry, 216 is 32. Yes. So the only possibility is this. These two cannot be the answer. And since in Kelvin itself the temperature is going beyond 33 to something, it cannot be less than 32. So this option is also gone. So this way the correct option is 3295 degree Celsius. I hope you understood this. Then moving on to the next question. A Carnot's engine has an efficiency of 50% when its source is at a temperature of this temperature of the sink. So formula for efficiency is this 1 minus Q2 by Q1. But in case of Carnot's engine, which is also an ideal heat engine, the ratio Q2 by Q1 can be replaced by T1 by T2. So what is basically T1, T2? T1 and T2 is nothing but the temperature of sink and temperature of source respectively. Q1 is the heat absorbed from the source, Q2 is the heat rejected to the sink. Here you have to be very careful. These temperatures must be in Kelvin scale, that is absolute temperatures. Absolute temperatures means Kelvin scale. So the efficiency is 50%, 50% means half, and T2 we have to find out temperature of sink. Temperature of source in Kelvin is 327 plus 273, which is 600 Kelvin. 600 Kelvin. So T2 by 600 is equal to 1 minus half, that is half. So therefore T2 is equal to half of 600, that is 300 Kelvin. Now 300 Kelvin, there is no option like this, you can see. So deduct 273 to convert it into what? Degrees Celsius. So 27 degrees Celsius is the correct answer. Moving on to the next question. The xt graph of a particle performing simple harmonic motion is shown in the figure. The acceleration of the particle at t equal to 2 seconds. Now students, you know that for a particle undergoing SHM, the acceleration is given by this. Acceleration at a position x is given by a equal to minus omega square x. This is the formula. And omega can be written as 2 pi by period of oscillation. So substitute the values here. You can see period of oscillation is 8 seconds because one complete oscillation is executed in 8 seconds. So 8 seconds, and x at t equal to 2 seconds, you can see x is 1, x is plus 1, so plus 1. So finally you get how much? Minus pi square by 16, because 2 4s are 8, 4 square is 16. So correct option is the third option. Then moving on to the next question. The ratio of frequencies of fundamental harmonic produced by an open pipe to that of closed pipe having the same length. Again, these are formula based questions. They should be in your fingertips. All the formulas should be in your fingertips. So first is the open pipe. Open means it is open on both the sides. On one side it has to be open, no? Otherwise you cannot produce any vibration. The air column must be disturbed in order to generate vibrations. So it should be open at least from one end. So in case of a open organ pipe, the other end is also open. That is what it means. Whereas in case of closed organ pipe, the other end is closed. Okay. So this is how you have this. So for a closed organ pipe, open organ pipe, the fundamental frequency, I take it as O. Velocity, speed of sound, that is speed of the longitudinal waves which are present in the air column, speed of sound of course, upon 2L. This is the formula. Whereas for a closed organ pipe, the fundamental frequency is velocity of sound upon 4L. So this is what we have to find. They have given that the length is same. So now check the order in which you have to find. Open organ pipe should be in the numerator, and closed organ pipe should be in the denominator. So when you divide this, half will stay here and 4 by 1 will go here. So 2:1 is the correct answer, because Vs by L will get cancelled here. Is it? So that's all in this video, students. Thank you so much.